Bismillahirrahmanirrahim. Good afternoon, guys. Today we'll try to calculate the value of acceleration, but experimentally. Everyone knows the acceleration equal 9.8 meter to each divided on second square. But today we'll try to prove this result is right or not. Sure, we can't calculate the specific result like that because at first we are not at the sea level and we have some change in the pressure. By that, near results will be acceptable. Now let me start from the purpose. The purpose from this experimental to determine the acceleration of free fall by using simple pendulum. Like I said at previous lecture, at some sources, it's written, the acceleration is written like A, at another source is written at J. All of these have the same meaning. Here, at this picture, here I have the string, approximately 1 meter, 100 centimeters, and by using this string and this ball at the end, we'll try to calculate the acceleration value. Here, I will try to displace this ball, this pendulum, by using simple angle. Theta here will equal 10, not more. It's not necessary. Here, there takes to make one complete oscillation. What does mean? When I take this ball by using angle equal 10 to this point, when I leave it, one oscillation, what does mean? One oscillation, that's mean the ball will go out from this point and to come back to the same original point. That means I have one oscillation. When a simple pendulum is displaced from its equilibrium position, there will be a restoring force. Restoring force, what does mean? This force will make the ball, the pendulum, to come back to original point. That moves the pendulum back towards its position. By that, the pendulum still directed towards the equilibrium position. Let's talk about the steps. What we will do here, we'll start from length from 10 centimeters, 40, 60, 80, until 1 meter. 1 meter. We'll displace the pendulum not more 10 theta, like I explained here. Theta will not be more than 10 degrees. Will take time to each 10 complete oscillation. What does mean? I will use my watch, will be specific function watch, to can calculate, to can determine some small points of second, because the result will be maybe 7.69 or 15.15 second. Okay, what does mean? 10 oscillations, 1, 2, 3, until 10. After that, I will record my result and keep going. Keep on. We'll do that to 2 times, T1 and T2, T2. Like I explained in the first lecture, to decrease our mistakes, we will do this technique by taking the average. Calculate T average, by that decrease the mistakes, like I said before, and make my result be precision more. It's important. And I explained some examples about that when I said when we try to calculate the temperature to a patient. And to be sure, we can take this temperature to many times, and after that take the average to take the specific temperature to this patient. Divide to on 10 oscillation. What does mean? Because that that's mean, sorry, we need temperature to 1 oscillation. And that will be clear when I use the column, because I need t square, not just t, to can plot my curve. About the string length, it will not, here it's note, the string will not be more 1 meter and not less 20 centimeters, because the results and the work on these two results will be difficult. Now let's take a look to the column. Here the pendulum length 20, 40, 60, 80, 100 centimeters. After that, after 10 oscillation, 1, 2, 3, like I said before, until 10, I will take my results. First one, do this process again to fold these two columns. After that, T average will equal T1 plus T2 divided on 2. By that, I will this will be to 10 oscillations. To 10 oscillations. To take T to 1 oscillation, I will take T average divided on 10. After that, I will put the square and fold this column. By that, the most two important two columns here is the length of the string and T square. My curve will be like that. I have linear relation between the length of the string and T square. By that, by increase someone, the second will increase too, and calculate the slope will be easy. Now, what's the benefit from slope calculation? Slope equal 4 multiple pi square divided on g. Like we know, pi equal 3.14. That means I can put g here, the acceleration, and can calculate it by saying 4 equal 4 pi square divided on slope. That's the main idea to determine the slope here. Now let's take a look how the question will come in the exam. Determine the acceleration of free fall by using simple pendulum according to the table below. Here you will work on 10 oscillation, but that's not condition. In the example, I can determine the acceleration by using the simple pendulum, by use 2 oscillations, or maybe I will give you the results in the column to 10 oscillations. You must be careful to this statement to can know you will divide the T average on which number. I will give you this first 3 columns, 1, 2, 3, and after that you will complete the other results alone. Here, T1, T2 at 20 centimeters, you will take the average plus between these two results divided on 2. After this to 10 oscillations to calculate T average to 1 oscillation, you will divide it on 10 to take the results like that. After that, you will take the T square to all of these 5 results to be like that. Approximately Here is written there, 0.8, 1.5, 2.3, 3.12, and let's keep going. Here, let's take a look to the diagram. It's very important here. Let me say that I divided this y-axis to 4. Why? Because the last result at t-square at y-axis was approximately 4, 3.81. That's mean my higher point will be equal 4. You can divide it the other results comfortably. 0.8, 1.5, 2.3, 3.11, 3.81. Here we have important thing. L must be, not should be, must be in meter unit. If you calculate the slope by using centime, you will take a result far away from the real result. By that, you will take a 0. Here it's important, must be at meter unit. All the others are clear, like I think. Now let's calculate the slope. Delta t-squared divided on delta L at m. The result slope equal 4.1. To be sure your results are going to the right point, slope must be approximately 4. Little bit less, little bit more. It's acceptable. By another way, your acceleration will be wrong. Slope, like I said before, 4 pi squared divided on acceleration. That means acceleration equal to 4 pi squared divided on slope. My result is 10.619 meter divided on second square. It's acceptable because, like you know, the real result is 10.8 meter divided on second square. That's it. Our lecture is done. Thank you about your watching or listening. Have a good day and see you in the next lecture.